Okay, now I'm going to show you why this formula works. Now I know that in the examples, I only used this part right here, sine of a to little a equals sine of b to little b. Honestly, that's all you really need. But for the generic form, of course, sine of c to c is also equivalent. But here, if I show you why this is true, then showing that this is true to this will be identical. So all we really need to prove is why sine of a to little a is equal to sine of b to little b. And I will give you a nice convincing way, a nice argument onto why this is true. And the idea stems from dropping a perpendicular from one of these angles. So I'm going to drop a perpendicular basically cutting through angle C. And here I'm going to create two 90-degree angles. Now this green altitude, I'm going to label it as H. And now here's what's going to happen. I just dissected this triangle into two smaller triangles, triangle 1 and then triangle 2. I'm going to focus all of my attention onto triangle 1. So notice here, for triangle 1, let's say I wanted to take the sine of A, the sine of the angle A. So by definition, sine is the ratio of opposite over hypotenuse. Now the opposite side, and again, we're emphasizing our attention onto triangle 1, so let's pretend like triangle 2 doesn't even exist. Or better yet, let me just extract it. I've extracted triangle 1. So now if I want to take the sine of A, we know that we need to get the ratio of opposite over hypotenuse. B is the hypotenuse because it's across this 90-degree angle, the one I created with the altitude. So sine of A is going to be H all over B. Alright, so now I'm going to play a similar game with triangle 2. I'm going to focus all of my attention on triangle 2. So let's go ahead and extract this triangle as well. I've extracted triangle 2. And now here we have this 90-degree angle. And let's say I wanted to take the sine of B, the sine of angle B. So here the sine of B. And again, by definition, sine is the ratio of opposite over the hypotenuse. So here we're going to get H all over A. So let's get H all over A. So we have two equations here, and let me brush off these two triangles to make more room. Now I'm going to play with both of the equations, beginning with this one. So here, if we divide sine of A by 1, we have a proportion. And we can apply the cross multiplication. So here we can do B times sine of A. So let's write that down. B times sine of A is going to equal 1 times H. And 1 times H, that's just H. We can do the similar thing on the second equation. This one, we can divide sine of B by 1, and we can apply cross multiplication. So we can do A times sine of B, and that's going to equal 1 times H, which is just H. Now notice that on the left hand side, H equals B sine of A. On this right hand side, H equals A sine of B. So if H equals this and H equals that, that means that these two things have to equal each other. So we can claim that B sine of A is equal to A sine of B. So we have a new equation. So here, let me just split this one up a little bit. And let's say that I wanted to clean this up a little bit. So one thing I can do is I can multiply the left hand side by 1 over A times B. But remember, whatever I do to the left, I have to do it to the right. So on the right hand side, I have to do the same. 1 over A times B. what's going to end up happening here is that this b on the numerator is going to cancel out with this b on the denominator. And here on the right hand side, we can see that this little a is going to cancel out with this little a on the denominator. So we have sine of a multiplied times 1, which is just sine of a. And on the denominator, the only thing that's left is little a. So sine of a to little a is going to equal, here we have sine of b times 1, that's just sine of b. And on the denominator, all we have left is little b. So here we are done. Sine of a to a is equal to sine of b to little b. And that is the law of sines. Now, depending on which textbook you get, they might do things a little differently here. So for example, let's say we had b sine of a and equals a sine of b. So what some people like to do is, instead of multiplying both sides by ab, they like multiplying both sides by 1 over sine a sine b, which is also valid, right? Whatever you do to the right, as long as you do it to the left, the equation stays the same. So here we have sine a sine b. Whoa, it's getting a little bit messy. So then what ends up happening is the sines end up getting canceled instead. So sine of a gets canceled here with this sine of a, sine of b gets canceled with this sine of b. So an alternative version of the law of sines would be b over sine capital B is equal to a divided by sine capital A. So this is another correct version of the law of sines. But I'm sticking with this one. I like this one better, but they both work. But just wanted to address that, just in case if you Google this or if you look at it in the textbook, you are aware that they are both the same thing. They mean the same thing.